I will record this and post it up later after my my afternoon class. And by the way, I'm sure some of you have friends in that class. All right, first move. Outstanding. The participation is off the charts. I love it. Multiplied by 3? Just a 3? We could do that. So we have on the right-hand side a cancellation of the 3's. Negative 2x equals 3 times 14 is? 42. The whole number bond action will help you with that, right? 3 times 10 is 30. 3 times 4 is 12. Add them together, 42. All right, next step. Divide by a negative 2. X is equal to negative 21. That's a good looking solution right there. If you want to streamline it, instead of only multiplying by 3, I could have multiplied by what? Negative 3 over 2. All right, so divide by multiply by something that will make the coefficient equal to 1, aka the inverse, the multiplicative inverse. All right. I'm going to multiply each part of this fraction by something. What is that something? 12. Now, if you overshot the mark, that's fine. Like, let's say you thought it was 24. You'll still get the right answer if you carry out the process from there on out. It's just you don't want to do it by 6 because that's not going to cancel out the 4. All right? Not the end of the world, but salvageable, manageable. So 2 goes, well, let me just actually do the, well, no, I'll do it this way. So 2 goes into 12 6 times. 4 goes into 12 3 times. 6 goes into 12 twice. Carry out the process. What we have left here is 6 times 3. I'll highlight it in yellowish. Does that look like highlight? Kind of. So these are the guys that are left over. Guys or gals. I don't know what I'm supposed to say anymore. So 18. Whoa. Not what I wanted. Not even remotely. All right. 18 minus 3x equals 10. Now it's just a simple linear equation. Simple as in there's no fluff. There's no fractions. You don't have to worry about too many properties. So my next move would be to do what?
18.
Subtract the 18. Meh. So 10 minus 18 is? Negative 8. Next move. Divide by negative 3. Making x equal to just 8/3, right? This is one of those cases where, I mean, I suppose you could write it as a decimal, but then you're kind of opening a can of worms. I don't think I would want to write, would it be 2 2/3, so 2.6 repeated. That's not as nice to look at as something like this. Even the mixed number equivalent doesn't look as nice. This is fine. And it's one of those things, it's a weird way of saying it, but we call this an improper fraction, you know, in the larger numbers on top. I don't know why they call it that way, because there's nothing improper about it. It's a fraction. It's a good-looking fraction. I don't see anything wrong with that fraction. Right? There's nothing improper about it. I don't know why they call it that. So don't shy away from it just because of the name. All right, number 3. First move would be what? I think I heard it. Multiply. So, distributive property, right? Got to know these names. We know that that means to multiply each part by the 1/5. So, you could do it that way, or you can multiply everything by just a 5. But this ends up being, I think, the way to do it that causes the least amount of confusion. So, 1/5 times k minus 3/5 equals 3/4. All right, I'm going to multiply. I want to clear out my denominator, so I'm going to multiply each fraction by what? 20. Little cancellations here. 5 goes into 24 times. 5 goes into 24 times. 4 goes into 25 times. I want highlighter again. So we're multiplying. And we'll be looking at 4k. I did it again. 4k minus 12 equals 15? I think so. All right, next move. Add 12. $4k is equal to 27. Next move. Divide by 4. And just quick question, what property justifies that move? Division property of equations, of equality. Or you could say the multiplicative inverse, depending on how the question is phrased. All right, so 27 over 4, improper fraction, not something that you could reduce. There's no number that divides evenly into both 27 and 4. All right, so we're good to go there. So most of you are asking about number 4. I don't think there are too many people asking about 1 and 2. It was like 3 and 4 that were the big ones. All right, so this one, the 4, the 12, and the 8. It's the same process in terms of finding that multiplier, that least common multiple, the LCD. It's just a little bit harder to find it. But I do want to find the number that I could multiply each fraction by in order to cancel out all the denominators. What would that number be? 24. All right, if that's a weakness for you, that calculator approach that I showed yesterday, the LCM, that could be your bailout. So what you would do, just a quick refresher, you would do LCM on the first two numbers, 4 and 12. It would tell you that 12 is the LCM for that. So then you would take that number, LCM of the 12, and put it together with the 8, and then it'll tell you that it's 24. All right, so it only works 2 numbers at a time, but that's all we need. If we know that we can work 2 numbers at a time, then we do 2 numbers at a time, incorporate the new number every single time we get an answer. All right. Maybe you don't need it for this one, but if I say 4, 12, and 17, 4, 11, and 17, you know, you could be at it for a while trying to figure that out, so use your calculator. 4 goes into 24 6 times. 12 goes into 24 twice. 8 goes into 24 3 times. All right, so we're looking at 18m minus 2m equals 21. After you multiply through with the LCD, and I'm assuming that the people who struggled on this problem struggled because of the LCD part, not coming up with the 24. Because after you get there, this is actually the easiest one on the whole sheet. Right? Because now we have like terms, subtract the coefficients. So we're looking at 16m equals 21, then divide out the 16, and we're looking at m equals 21 over 16. Now, if you're not sure if it's something that can be reduced, let your calculator do the work. All right, so what you would do is type in 21 divided by 16 in your calculator, and then hit math, enter, enter. All right, that's math frac. The math menu, and then it converts over into the fraction form. All right. If you get a fraction that's different than then the division problem that you put in, then what happens is it reduced what you started with. If you get the same exact thing, it's telling you that it's not something that can be reduced. All right, that makes sense? Hopefully. A little bit more than maybe last night.